We will solve more problems on estimating arc lengths. Here we have a problem where we need to find the arc length of the portion of the curve y equals x squared with x of value greater than 0 but less than 1. Now looking over here, y equals x squared, this is a parabola. So we need to estimate the arc length of a parabola from this limit from 0 to 1, not the entire, it just goes up to infinity, right? A parabola. So only from 0 to 1, wherever it is, that arc length needs to be estimated. Now the step 1 would be differentiating this function and writing the limits. The x squared, a differentiation of x squared is 2x. And the limits are 0 and b, the final limit b is 1. Use the formula, directly substitute over here. A is 0, b is 1, and f dash of x is 2x. And you can directly put it in the calculator using the symbol. 1 plus 2x, that is alpha and x over here, square. Sorry, I forgot the square root. That's very silly of me. Now, one more thing is it's better to regularly clear your calculator. Sometimes it might be in radian mode or it might be in other mode. So it's better to clear. And now applying over here, 1 plus 2x, that is alpha x, close the brackets, square. And the limits are from 0 to 1. And you will get the answer 1.47. It's about 1.48 basically. So that is the answer. Similarly, let's see another comparison problem. Over here, they have asked us to compare the arc lengths of power function. Find the arc length of the portion of the curve y equals x to the power 4 at the same limit where x is greater than 0 but less than or equal to 1, and compare the arc length with the portion of the curve y equals x squared on the same interval. We just solved this, y equals x squared. Now let's solve it for y equals x to the power 4. Differentiate. Over here it'll be 4x to the power 3 and limits are 0 to 1. Write it in the formula over here. All you need to do is because we just now solved the previous problem, I'll just change it over here. It is 4x to the power 3. And the same limits, everything is same. The answer is 1.6. It's basically 1.6 units. Now, we saw in the previous problem, when we solve using the formula, that is derivative of this is 2x, and when you solve it, you'll get 1.48. Now, what is the difference? So they have asked us to compare. If you compare these both, you will come to know the first one, x to the power 2, you can see is a bit smaller compared to the other one. You can see the arc length. There's a small difference because there's a dip, there's a sag over here, isn't it? The sag is for x to the power 4 graph. So you can see the comparison is about 7.5%. If you're wondering how we got it, you can just find the difference between 1.6 and 1.48, and we will, because 1.6 is greater, I will divide by that, so we can see it's about 8% or 7.5% larger to the other curve. So this is how we can easily solve any of the arc length problem just by knowing the formula. Derive it, substitute it, and you will get the arc length.